So let's set a little bit the context here. Companies are typically moving their workloads across different generations of server computing, to call it this way, okay? As a meeting similar to this one 10 years ago would have been all about the latest and greatest about hypervisors. Now, the latest features in VMware, the new Hyper-V things, how KVM was starting, to gain new followers, Xen, and so on. Okay. Nowadays, hypervisors are basically commoditized, right? So, more or less, all the hypervisors do the same things. Of course, there are differences. Hyper-V does some stuff, KVM does some stuff more, ESXi does some other stuff, and so on. But at the end of the day, when it comes to starting virtual machines, connecting, I don't know, some storage, connecting some NICs and everything, they all do the same things, right? The next generation, which is the one we're caring about, is the one with infrastructure as a service. Now, is at the end of the day, the big difference between the simple virtualization and a cloud, so infrastructure as a service, is the fact that everything is software defined, So I want to spin up a machine, well, there is a REST API, I'm calling in through Horizon to my client or whatever, and I spin up a machine. Do I want to create a network or create a port on a network? Well, I have software-defined networking. Do I need to create a LUN on my storage or on Ceph or whatever? I have software-defined storage, okay? So it's the software-defined everything that makes the difference between the old-school virtualization and infrastructure as a service, okay? That's where everybody is typically moving their stuff today. On top of that, you have applications and workloads, okay? There is a lot of discussions about the fact, well, is Kubernetes going to be the next OpenStack and everything? That's total bullshit, right? So there are two completely different things. OpenStack is infrastructure as a service, and Kubernetes is container orchestration. End of the story. You can use, of course, Kubernetes to deploy OpenStack. That's a great idea. Okay, like, for example, Kubernetes does. And you can have Kubernetes orchestrated on top of OpenStack or any other cloud. But Kubernetes itself is not going to replace OpenStack, exactly like OpenStack is definitely missing its target if it's going to handle containers the way, of course, for example, Kubernetes or Mesos are doing it. There has been quite some criticism, if you want, from this perspective around the fact that OpenStack, with the big tent and everything, started expanding his focus outside of the core projects towards things like, in the end, didn't have really so much traction, right? Think about Magnum, for example, and so on. Anyway, so that's where typically everybody is today. Some vendors, for example, Microsoft and so on, are pushing a lot their marketing message about serverless. The idea of serverless is pretty simple. You as a developer won't care about server semantics anymore, so the entire server paradigm basically disappears for you, and you care only about some applications-related APIs like, I don't know, Azure Functions and everything that you're calling from your applications, and those will actually do all the magic for you. At the end of the day, it's serverless only from the perspective of the developer. Behind the scenes, you still have servers, you have hypervisors, you have physical servers and everything, okay? So let's distinguish, of course, the marketing crap from the reality. So, but it's clear that that those are different layers that we put on top of that. Containers, of course, is what makes everybody happy, because a container is just a bunch of processes which are wrapped up in a container and deployed on some cloud, right? So when we're talking about migrating workloads, we are talking about doing exactly this type of flow. And the ones in which we are particularly interested in this moment is this one. So this is a nice diagram. I didn't do it, actually. It's from Stephen Orban from Amazon, but I like the way in which it's put down. Okay, it's a little bit small here on the screen, but it gives you an idea about all the options that you have to go from existing workloads on an old platform to the workloads on the new platform, okay? And you have a bunch of ideas. For example, one of them consists in repurchasing. If you can just get rid of the old software and buy a software as a service, a SaaS solution, okay? Think about, I don't know, Salesforce, okay? And just get rid of the old, well, good for you, perfect. But for most applications, this won't work. Either you rewrite them, so the typical cloud Evangelists will tell you, oh, if you want to move to the cloud your workload, you have to rewrite it. And you say, well, I spent 20 years writing my line of business applications. I'm not going to rewrite it in 1 month, okay? So most probably I have to take my existing workload and move it to the cloud as it is, while my next generation will be cloud native, no? Scalable, and so on. High available and everything. So the next one, replatforming. It's also something which is very common and consists in taking your existing application and make it work in a different platform. Containerizing is just a form of replatforming. I take my, for example, PHP website, my 20 years old Java or .NET application and everything, okay, not 20, but almost, or even something that I wrote yesterday for the matter of it, and I wrap it up in a container and I ship it, through some orchestration to my cloud, okay? Perfect, great. It works, but it will take, of course, quite some work in doing this. And most important, also very clear understanding of how your application works. There are lots of companies specialized in doing this work very successfully. So we also do it for our customers. And I think it's a great way to transition workloads from on-premise to cloud. Or better said, from legacy on-premise to cloud. The other interesting way, which is the one in which we are focusing the rest of the talk, is this one, rehosting, also called lift and shift. The cloud purists are typically making strange faces when you say lift and shift, because it means like taking old virtual machines, which were meant for an previous generation of virtualization, which typically you were relying on your host for everything related to high availability. Think about VMware vMotion or Hyper-V failover clustering, okay? And you move to the cloud where typically all the high availability is handled by the application themselves. Virtual machine dies, application dies. Short story, no? So that's why a cloud native application is meant to have multiple instances, with anti-affinity and blah, blah, blah. So why is lift and shifting so interesting? For a bunch of reasons. One of them is the fact that the virtual machines are black boxes. We don't care what's inside of the virtual machines. We take them, we lift them, we shift them, we make them run at the target. Okay? The second thing is that by doing so, you're improving a lot your total cost of ownership, because of course it's true that you're not exploiting fully the capabilities of the cloud, okay? But you're also, at the same time, not paying VMware licenses anymore, for example, okay? You can get rid of your own infrastructure by moving your workloads to the new cloud, okay? And at the same time, you can start using the money that you spare to write new applications, for example. Plus, it's true that you don't use all the advantages of the new cloud, but you have a lot of them that you can still use. Multi-tenancy, software-defined networking, software-defined storage, all those things, so you still benefit from them, right? Lift and shifting is not just taking my VMDK file or files from the disks, moving them over to, let's say, KVM and via OpenStack and starting it. That's not going to work. There are also a lot of steps involved. For example, you typically have different disk formats. I might have a VMDK, VHD, QK2, RAW, whatever it is, on the source, and a completely different format on the target. Typical example, if I move VMware to OpenStack, I have VMDK on one side, and if I'm using KVM as my hypervisor in OpenStack, I'm going to have QK2 or RAW. If I have Hyper-V, I will have VHD or VHDX, and so on. I have also completely different sets of synthetic drivers. I have, for example, VMware tools in VMware, virtually on KVM, and so on. That means that when my Linux machines start, if the initRD images don't contain the right drivers, the right kernel modules, they simply won't start. So before starting the machine on the target, I will have to rebuild all my initRDs, right? If I have SE Linux job is to detect that I'm trying to run from a different hardware and not let me do that. So we have to tell SE Linux that the new disk we are booting from is good. Then there is the networking. I will have completely different PCI IDs. So what used to be called the 8080 most probably is going to be called whatever else on the target environment, okay? Unless I create a rule in etc, udev, and so on, that tells that that specific MAC address has to be called like it used to be called before, no? Because again, our job is to do the minimum amount of work necessary so that the machine will start on the target exactly like it was on the source. So if our users won't detect any changes inside of the virtual machines, then we win. If you screw up stuff, then we don't win, okay? Provisioning agents need to be injected. For example, you need to add Cloud Init on Linux, Cloudbase Init on Windows. If you're running on Azure, the WA Linux agent, blah, blah, blah. Okay, so far for setting the stage. Introducing Coriolis. Coriolis is this project that we wrote for migration as a service. The goals were to have a fully automated lift and shift migrations to and from any cloud. Scalable from one migration to 1,000 or 10,000 or whatever at a time. REST API for full automation and Keystone identity management. And here is the architecture. A little bit small, but of course you can see the slides later. It's written like an OpenStack project. The goal is, of course, to, at some point, put it under GitHub, OpenStack, and maybe upstream it as well. Just one point. We as a company do a ton of upstream OpenStack development. We are always in the top 20 contributors. We are typically focused on all the Microsoft-related components. We develop and maintain the Hyper-V Nova driver. We ported OpenVSwitch to Windows, so Neutron driver, plugin mechanism drivers, Cinder storage drivers, and everything. Okay, so in the moment in which we wrote this application, this project, we wrote it exactly like an OpenStack one because we were very familiar with doing that. So everything is Python. You have, of course, a GUI and a CLI. A REST API. So this is my REST API endpoint, which is of course using Oslo service. All the identities managed by Keystone. So the user will fetch a token from Keystone and then use that to get here to the endpoint. From here, I get all my microservices, a conductor, a scheduler, and some workers. They are talking among each other via MQP, specifically RabbitMQ, Oslo messaging. Okay. There is a database, whatever SQL Alchemy can deal with, typically MySQL, okay? This is just for containing information related to my migrations. Workers are in charge of connecting to the source and target clouds. So if I'm moving from VMware to OpenStack, I will have a worker talking to VMware and another worker, or even the same one, talking to OpenStack on the target side. If I have to connect to VMware and to another OpenStack cloud or AWS cloud or whatever else, I will have to store credentials somewhere, right? And the last thing I want is to see them traveling in clear text through my infrastructure. Where do we put them? In the OpenStack project, which is meant to handle secrets, which is called Barbican. Okay. How does that work? Well, it's pretty simple. The user has a token, creates anyway a secret inside here, configures that endpoint in Coriolis, and so in the moment in which you get to the worker, Coriolis can use the same token from the user to go and fetch the secret and pass it over, okay? So nobody's actually accessing the credentials until here. Another thing, Coriolis is completely agnostic from the underlying cloud. So Coriolis has no idea about what's going on in VMware, in OpenStack, in AWS, in Azure. Who's taking care of that are plugins which are running here called providers. So I have a fully decoupled solution in which basically whenever I want to add a new cloud, I simply implement one of those providers which know how to talk to a new cloud, okay? Supported clouds and virtualization solutions, OpenStack with all the possible various hypervisors, Azure, AWS, VMware vSphere, Hyper-V and System Center, Zen Server, OVIRT, Oracle VM, and by the way, Oracle Cloud, and GC coming soon, okay? And also the Oracle Bare Metal Cloud is coming as well. The part in which, that I was explaining before, in which when the machine starts on the target cloud, right, there are a lot of steps to be performed, you know, injecting drivers and all that stuff, is what we call OS morphing. So what's happening here is that, again, we have a series of plugins. So there is a temporary VM that we use to check the content of the disk that we just moved over. And those VMs, temporary VMs, will detect what type of operating system runs there. So let's say that it detects it's an Ubuntu 16.04. Then it will have initialize an instance of those specific OS morphers, which will know how to deal with that specific platform and operating system. Whenever I add a new platform, a new platform and a new operating system, guest operating system, I just have to write a new morpher, which is simply implementing a given set of interfaces, and there is a factory which is simply implementing the right one, okay? So this architecture is completely decoupled, can be extended, and there is nothing that ties, let's say, Coriolis itself to any specific operating system. At the moment, we support Debian, we support Ubuntu, we support SUSE, RHEL, CentOS, and Oracle Linux, Fedora, OpenSUSE, Windows client, all the supported version, and Windows Server, all the supported versions, okay? So basically anything that makes sense. Whenever a customer or a user or whoever comes up saying, hey, I want to support, I don't know, Arch Linux or whatever else, it's pretty simple to add support also to that one as well, because again, the entire architecture is fully decoupled and cohesive from that perspective. There is a REST API and a command line interface, which I'm going to demo right now, and of course also a graphical user interface. So resolution is what it is here, so bear with me. So this is my VMware environment running in our data center in Timișoara, okay? So a bunch of machines, I have an Ubuntu 14.04 there. I get to the console. So here I'm inside of a machine and I just write a file with hello OpenStack, okay? So the reason I'm doing this is that you will see that I'm migrating the machine while still leave it running on the source cloud. Next, if I look here, and again, resolution is not helping us, but I think we can make it. Visible enough? Yeah, kinda. So if I do an OpenStack endpoint list or a Keystone endpoint list, if you want to use the old client, I have a bunch of endpoints. So this is just targeting, you know, a regular OpenStack deployment. And you can see here that I have one endpoint that it's new, which is this one, which is of type migration, named Coriolis, and with a bunch, of course, of URLs to reach it. No? Exactly like you will have a neutral one, a Cinder one, another one, and blah, 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 okay? So plain simple service, exactly like you will handle any other OpenStack service. So this means that when I do something like this, what's happening is that my command line interface, which by the way is implemented like the OpenStack command line interface using Cliff as a base, I'm calling my REST API, and in this case I'm telling you, hey, get me the list of endpoints from this specific project for this specific user, okay? I got a Keystone token and I connected there. So I have these endpoints. An endpoint is simply something which says, this is a cloud connection to a source or a target cloud. For example, I have an OpenStack one here, I have a VMware vSphere one, and I have an Oracle VM here from a previous demo. Let's see how the OpenStack one looks like. Of course, it has an ID. OpenStack endpoint show. Coriolis endpoint show. And you can see here that it has a name, a type, a description, and a connection info, which is nothing else than a secret ref from Barbican. Barbican, again, is the OpenStack project for handling secret. So if I take this guy over here, and I do barbican secret get -- payload, and I pass in the ref, I get my actual payload. So this stuff is encrypted, I decrypt it, and I look at it. So it's telling me, look, identity API, username, password, project name, I don't know, auth URL, and so on. So the same type of stuff that normally you pass into environment variables, no? So this way I can connect to my OpenStack Cloud. Same thing if I look at my VMware endpoint, right? Now, if I do a Coriolis replica list, I see a bunch of so-called replicas. A replica in Coriolis is a one-to-one copy of storage from the source cloud into the target, done in an incremental way. So whenever I do the first time a replica, it will copy all the data from a virtual machine from the source to the target, without stopping the source virtual machine and without interfering with the business continuity. The second time that I execute a replica, it does it incrementally. So it copies over only the changes from since the last one I ran it. How does it do it? I will explain it in a second. So this thing is used also for disaster recovery. So for example, if I take, so this is my replica. If I do Coriolis replica show, taking one of the replicas over there, I see this is it contains only one instance. So it tells me what specific virtual machine I'm going to replicate, which is incidentally the one that I was showing you in VMware. And then I have a bunch of information. The source endpoint ID is nothing else than the GUI of VMware, of the endpoints that I showed you before. And destination endpoint ID is the ID of the target endpoint, OpenStack. Then I have some information. For example, it tells me here that if I have a network called VM network on the source, it has to be mapped on a network called private on the target. Because of course, VMware has a very limited notion of networking, while OpenStack is a real cloud, and so it has full software-defined networking. So I have to map the name of the networking in VMware to the name on the target cloud. Much easier if I'm doing, for example, AWS to OpenStack, because I have software-defined networking on both sides. So I can read also the entire configuration on the network on the source and replicate it on the target. Then I can execute the network. Here I have the history of my execution, with, as you can see, we're all completed. What can I do? I can do Coriolis replica, execute, and this will actually perform an execution of the replica. And if I do Coriolis replica execution show, and I take the idea of the one that it just created, I can see all the details, no? And just by the way, if I do again a show on the replica, it tells me that there is an execution currently running, which is the one which is being performed at the moment. So let's go here back. Okay, the screen resolution is what it is, but you see that there are a bunch of tasks. For example, get instance info, connects to the source cloud, fetches information about the VM and the disks, and then pass them over to the target. On the target, it says deploy replica disks, creates or reuses volumes, Cinder volumes created on the target. In this case, it's incremental, so we reuse it. Then here it will say deploy replica target resources, which is a temporary virtual machine on the target that we spin up on the fly, and we assign a Newton port, a floating IP, and a security group, and we simply connect via SSH to execute some commands, which is actually what it's doing at the moment. So I can refresh this. And we already passed that step. And now it got to the point in which it created a snapshot on VMware, so fully app consistent and cache consistent, VMware caching, okay? Performing incremental change block tracking replica. So change block tracking is the same VMware API that backup applications like Veritas or VM and so on are using. So we exploit them in the same way from Python. No? So, and it tells me, look, this disk is 5 GB in size, but since the last time that you executed a replica, it only 5 MB changed. I executed a replica shortly before starting the demo, so that it was very fast. No? So it's incremental, so I'm copying over only those 5 MB, and it's very fast. How do I copy it? From the source worker, it's opening an SSH tunnel to the target worker VM. Inside of that tunnel is sending up compressed chunks of data, 10 MB at a time, okay? And on the source target, we have a very tiny application, which is just taking these chunks of data, expanding them, so decompressing, and writing them inside of the right volume at the right offset. So this way, even if I have a 1 TB disk and only 100 GB are written, I will have only to transfer the 100 GB, okay? When it finishes, it removes the snapshot, so my machine on VMware is still running, and it cleans up everything else. So if I run it again, I will see that it's finishing, and then it's removing worker resource, and you see my tasks are completed one after the other. The tasks are sequential, but tasks which are unrelated will be executed in parallel. For example, if I'm migrating 5 virtual machines at a time, they will just go all in parallel, right? Now, this is finished, and if I look also at the status of my virtual machines, it stays completed. What can I do now? So at this point, the data related to that particular virtual machine is sitting inside of one of these volumes over here, okay? And it's a copy byte per byte of the content of the VMware one. So it's not yet ready to be started on OpenStack, because that's actually a VMware virtual machine. So we have to migrate the replica. Coriolis, replica, migration, deploy replica. And this is actually taking the content of my disks, taking a Cinder snapshot, creating a new volume from the snapshot so that we don't touch basically the original replica, and inspecting the content of the virtual machine, detecting that it's Ubuntu, performing the DNS changes, and starting the machine. So all we have to do is simply take the idea of this migration that we just created, Coriolis migration show, and wait for it to finish, okay? It will take a little bit for doing all the work. If I look at OpenStack here and I look at instances, I will see that there is a temporary instance, which is the temporary machine which is thrown up, to do all this work. So Coriolis is in charge of creating and destroying all those machines. Okay, this will take another few seconds. While this is running, I will show you that there is also a graphical user interface for this work. Which is this one. And here, the concept is the same. So again, there is a REST API behind, and then in front I have a command line interface, a web interface, and whatever I want. But they perform the same identical things. And here I can see that I have a replica, VMware Oracle VM, VMware Oracle Cloud, and VMware OpenStack here, no? Could be also OpenStack Oracle Cloud, Oracle VM to Oracle Cloud, and so on. Pretty soon, Oracle Cloud V1 to Oracle Bare Metal Cloud, and blah, blah, blah. So if I take any of those, doesn't matter which one in this case, I see even here the same context that I was seeing on the command line. Okay. So I can anytime click execute, and this will start an execution of the replica. And since I have the same APIs behind, it will simply show me the same data, but here it does it in a more fancy way because it's a GUI, right? But you can see that it's the same identical content that you saw on the command line interface. Let's back here and let's see what's happening. Oh, look. So we went beyond. We already discovered that we attached the volume to the worker instance, connecting to SSH host, attaching all the volumes, inspecting the volumes, meaning mounting all the possible volumes, including LVM, so it could be nested, you know, and then inspecting the operating system. And look, voila, we found an Ubuntu 14.04. What do we have to do? We have to remove the OpenVM tools because we don't need them anymore coming from VMware. Those are the VMware tools, right? And it will have to inject Cloud init. And voila, adding packages Cloud init. Dismounting OS partition and then cleaning up all the stuff we had before, making sure the volumes are bootable, creating the migrated instance. So now Coriolis is talking to Nova, right? So Coriolis is talking, of course, to OpenStack APIs here. And then cleaning up, removing snapshots and blah, blah, blah. So while this is running, I think I can already go here, refreshing my instances. And voila, there is an Ubuntu 14.04 machine running here. Let's see if it's true that the content is identical to the one that we had on VMware. Which, by the way, my machine on VMware is still here up and running, so nobody touched it.
Issue uptime.
Sorry?
Issue uptime.
Bueno. Inside here? Yes. Okay. It's probably running since forever. 2 days and so on, okay. Pinky promise, it's true. Well, here, so I got inside of my machine, I got to the console. And here, as you can see, it boots. You can recognize already by all this output here that Cloud init is running. So if everything worked as expected, now I will have the same file that I created over there. And actually we do. Okay. So here, of course, my uptime will be 0 because this machine just started, right? So now I could do more changes in my source machine, delete this migration, start a new one, and we'll see completely the changes, right? The same works for Windows and any other Linux machine, as I was saying before. Fully automated, fully resilient, fully idempotent, and blah, blah, blah. OK, I think that we don't have much more time. I think I can just go to this slide. Questions?
Can you migrate also networks or just instances?
That's a great question. So the idea is to migrate every possible virtual workload, including network storage, blob storage, and virtual machines, of course. No? We are adding right now also the migration of the entire networks, and not only of the individual endpoints that we have. But for example, one thing that I said before, we preserve even the MAC address. So we read the MAC addresses from the source cloud if available, and we preserve it on the target. We preserve the same IP address. For example, this includes also that I can read for the source cloud what IP address that machine had. I can have also multiple NICs. So each one of those what IP address have, create a neutron port on the target with the same IP in the same subnet, and assign it to the same one, okay? I can also assign the same identical floating IPs. So all that part, as long as I can read that information from the source cloud, I can anytime replicate it on the target. It becomes only difficult, for example, from VMware, because VMware doesn't have that type of information. From VMware, I just know I'm connected to the switch, gata, right? While if I'm reading from OpenStack to OpenStack, and by the way, lots of people are using this stuff at the moment to migrate, for example, from an old OpenStack to a new one. they got stuck, for example, on Icehouse or on Kilo, and now they want to migrate to Okata or to Pike pretty soon, or to Newton. So since migrating in place will be impossible because they will have version to version, what they do is they spin up a new OpenStack, and they use Coriolis to simply migrate all the VMs and all the workloads from one side to the other.
And in that case, you can migrate to the network.
Everything. I read everything, I copy over everything.
Okay.
Yeah. It's fully software defined, so it's basically a software defined migration. So that's also the big difference between other tools out there. So that this is software defined exactly like the rest of the cloud. You saw that there is a REST API and everything. Other questions?
Yes, do you support physical to virtual?
Excellent question. We support it. At the moment, we supported it by booting the source machine with an ISO, basically, that will simply read the content and get it out.
Like a ghost for Linux.
Yeah, correct. In the future, we want to do it with an agent that will run inside of the machine. And even if the machine is running, we would basically take a VSSS snapshot, for example, and read the content out of the snapshot. Okay.
So offline.
No, that will become, with the agent, it becomes online.
Yes, but currently you support it.
Yeah, correct.
How does the Coriolis replication handle data being written on the source machine while the replica is running?
That's a great question. I was mentioning before, yeah. For example, Oracle or SQL Server, they know, so for example, if they run in a Windows machine, what's happening is this. In VMware, you take a snapshot, you have an option which is called queuing, and that will basically allow you to take an app consistent snapshot. So VMware talks to the VMware tools. VMware tools talk to VSS in Windows or file system freeze in Linux or whatever else. And that component of the operating system will have providers registered. For example, Oracle database or SQL Server database, they have a VSS provider. At that point, the provider knows, oh, there is a snapshot in process. So a database, for example, works like this. You have data files in Oracle containing extents, for example, no? And you have log files. So normally a database writes inside of the log and then makes at the checkpoints, writes the data inside of the data files, no? So what's happening in that case, the database engine knows that it has not to write anything inside of the data files and writing only on the logs. So you have zero risk to end up with a transaction which is half written and half not. In the moment in which you go to the other side and start the machine on the target, the Oracle service starts, and the same also for SQL Server, looks inside of the logs, discovers that there are already some checkpoints which need to be rolled forwarded, and simply applies all the transactions which already have been committed and simply writes them to the data files. So eventually it's fully consistent, atomic, and everything, the ACID database properties. Other questions?
I have two questions.
Yeah.
First is if you are doing this migration live.
Yeah.
So if you are turning off or if you need to turn off some services on the main server.
Yeah.
You want to migrate it. Or you are doing this during the operation of the server.
Mm-hmm.
You can do this live or not?
Yeah, well now what we showed is fully live, no?
It was live. Okay.
Yeah.
So all the services are in place on the old
Yeah.
machine until you make the migration.
Yeah.
Then you can run on the migrated area.
Yeah, correct.
And you can cancel the initial machine.
Yeah, so one of the options, so for example, when I execute the replica, there is one extra command which is a shut down the source machine, no?
Yeah.
So if I want, so now in the demo that I showed, I simply left the source running, no? But what people typically do is that they perform the replica, that if you have a terabyte disk, it will take some time, no? Yeah. And only at the last possible moment, I shut down the source, perform the final replica, start the target. Okay. That's what typically people do.
So basically the migration ends up when you kill the source.
Yeah. Well, and I start the target. Yeah. My goal is to minimize the amount of downtime that I can have, no?
This was the
yeah.
idea of the question.
What we don't have, of course, is that we cannot migrate the memory, because there is a memory running on VMware on one side and KVM on the other. Plus, we work only by talking to the APIs which the cloud is offering. We don't expect to install anything inside of OpenStack or VMware, okay? So at that point, we are limited to what the cloud could offer. Yeah. Okay, thank you. Anything else?
Is there any chance of conflicting IPs on the source machine and the destination machine?
Absolutely, yes. So that's of course a responsibility of the deployer. So if the deployer says preserve IPs, normally what's happening is that you are deploying in OpenStack inside of your private network with your own tenant network, with your own segmentation ID, VLAN, VX.
Client needs to access the source machine, and
Yeah.
it will continuously need to access that single ID.
Yeah.
It will need to be defined on the floating IPs subnet of
Yes.
OpenStack.
In that case, it's paramount that you shut down the source before you start the target.
Yeah.
That's of course a limited use case in which you have both source and target environment in the same subnet.
Yeah, but that will mean no downtime for the client connecting to the.
There will always be a small amount of downtime, okay?
Small.
Yeah. Depends of course on the time starting and everything, okay? Any other question?
One more.
Yeah?
Does it care about single backend? Can be local, can be set, can be anything?
Irrelevant, because we talk only to the OpenStack APIs. So at that point, also you can also specify the volume type. So in the parameters you pass, you say, if you want to have more than one, for example, you have, I don't know, a Ceph one, a GlusterFS, and I don't know, a 3-par1, okay? You can say I use volume type, whatever, okay? Whatever you have in the configuration. Okay, welcome. Thank you, guys.
But there are no more questions?
Yeah.
Product is that license or is it open source or open?
Yeah, great question. So our goal is to open source everything, okay? So what we did at the moment, we open source the core of the project, the big bulk, and we keep some of the providers as proprietary, okay? As soon as the project will have enough traction and we are sure that nobody will run away, let's say, with our project to say so, we will open source everything. So that's our goal. Final goal is to make this thing as one of the upstream projects. So GitHub, OpenStack, Coriolis, okay? So there are a bunch of projects. There is Coriolis Core, Coriolis, for example, Coriolis Web, which is the UI, is fully open source. The Coriolis, the Python client is fully open source. The core is open source. And some of the providers are and some are not, okay? So that's the goal we have at the moment. And each provider has its own project, so anybody can also create their own providers. And the idea is that anybody can theoretically extend it the way they want, no?
Some of the providers are also open source, right?
Yeah, that's it. So again, our goal is to open source everything. We are an open source company. We try to open source as much as we can. Okay, thank you.